Foteini Savvidou, a Microsoft Learn Student Ambassador from Greece, and I study electrical computer engineering at Reusable University of Thessaloniki. I'm so excited to be here tonight and co-present this wonderful Microsoft Learn live session with you.
Awesome. Now, I mentioned that this is Microsoft Learn Live. So if you're not familiar with Microsoft Learn, it's our free online training platform to help you learn Microsoft products and the skills that you need to be successful in today and tomorrow's IT landscape. Now, the Learn module that we're going to be covering today, Automate Cloud Resource Management, was developed in partnership with Carnegie Mellon University. And you can find the Learn module that we'll be covering at aka.ms/CMU Automate Cloud. You can head over there now if you'd like to follow along, or go back later and complete it afterwards. And then you can find some other great modules to continue expanding your cloud knowledge. Now, as we kind of level set here, if you have a basic understanding of cloud computing, including the different service models, cost management models, and how cloud provisioning works, you're going to get the most out of this conversation. However, if you don't, this can still be good information, and you can brush up on that background information on Microsoft Learn. The Azure Fundamentals Learning Path will help set you up well. Foteini, have you gotten a chance to get familiar with these concepts?
Yes, I know that stuff, and I actually passed the Azure Fundamentals exam a few months ago.
Oh, wonderful. And what resources did you use to kind of help get through that?
I used the Microsoft Learn module from the Azure Fundamentals.
Oh, wonderful. All right, so let's talk about what we're going to cover today. When we finish this learning module, you're going to have a better understanding of cloud automation tooling. You'll be able to explain the concept of infrastructure as code and the advantages that it offers, and you'll be familiar with infrastructure orchestration and Terraform's role as an orchestrator and how it differs from conventional configuration management tooling. All right, so what does that mean we're going to cover today? To get there, we're going to talk about what automation is and why it's important. We'll cover scripting cloud tasks and move into infrastructure as code as a concept, and then take a look at some of the tools in that space. And finally, we'll cover Terraform and its role as an infrastructure orchestrator. This is Learn Live, and we want you to be involved. Our expert moderators are standing by to help answer your questions in the chat, and Foteini and I will even answer some of those live right now as we go through the content. So ask those questions. Now, you can pop into the chat on Learn TV. If you're watching us on one of our partners on YouTube, Twitch, or Twitter, head on over to Learn TV and join the chat. We'll be asking you some questions as well, which you can answer on Learn TV. Now, if you're in that chat that I just mentioned, we'd love to get to know a little bit about you. We're going to add a couple of polls to the chat, so you can go head on over and answer them for us. Now, we're going to start with a little getting to know you. And Foteini, you mentioned you're a student. Could you tell us a little bit more about that?
Yes, I'm a third-year student in the field of electrical computer engineering, and I'm interested in cloud technology, software engineering, and AI. But I'm a beginner in cloud automation, and so I will learn a lot of great stuff from you today.
Thanks, Foteini. And I'm happy to have this opportunity to cover a topic that's been central to my career. While I work in advocacy now, I've worked as a systems administrator and a software developer, including building configuration management tools. Cloud automation and cloud provisioning has kind of been central to what I've been doing over the last 5-10 years. So let's see what our audience has to say about their backgrounds. See if we've got any responses here. Now we've got a good mix of, it looks like we got about a third of folks who are students, a third professional developers, a third are IT administrators, and we even have a couple of teachers in the audience as well. Awesome. Now, we've got one more question for you. And have you used Microsoft Learn before? How about you, Foteini? You mentioned some of it, but what else have you used Learn with?
Yes, I use Microsoft Learn, and I think it's a great platform for learning and practicing new skills. It offers more than 2,000 free modules and hands-on exercises covering a wide range of topics. I have completed 70 of them, and so you can do that too. Go to Microsoft Learn and find great resources to level up your career, learn new skills, and prepare for the Microsoft technical certifications.
Did you say you completed 70 of them?
Yes, I have completed 70 of them in the
Wow.
last 6 months.
That's probably more than I've done. So wow, congratulations. That's awesome.
Thank you.
So let's check and see how our responses are coming in. So far, it looks like the majority of people watching have used Microsoft Learn before, which is great. I've used it myself to kind of ramp up on new stuff because there's so much stuff in the cloud that you just can't know all of it, right? Even me working for Microsoft on the Azure team, there's no way you can know it all. So Learn's essential there. All right, let's get into it now that we've kind of got a little background of our audience and of ourselves here. All right, so why do we need automation, right? As we move into the cloud, our day-to-day operations changed. Back when I managed a data center, if I wanted more capacity, then I went out and I bought hardware, I installed it, configured it, usually right from the data center, ran some wires, hooked up some fiber channel, all sorts of fun stuff, right? But then that's when I would finally be able to get to working with the software side of things. Now, when we move to the cloud, all of these things are an API or a command call away, and they become software problems. Now, because the cloud makes my infrastructure management into a software problem, I have to use these specially built UIs, command line tools, or programming languages to interact with it. When I build cloud environments, one usually isn't enough. We usually have to repeat that process over and over, either to scale out or to create new environments to support development, testing, and different customer experiences. This can lead to repetitive work, which opens the door to human error. Even small differences in how environments are provisioned can lead to operational problems over time. And if I have to work in multiple cloud environments, maybe from different cloud providers, I often need different tools for each one. So what can help here? Well, that's where automation comes in. So, Foteini, what can you share with us about automation?
So, automation is the use of technology to perform tasks with reduced human assistance. This means that operations that were previously performed by humans can now be recorded, repeated, and trusted to perform the same task the same way each time. For cloud administrators, automation comes in 3 forms: scripting, configuration management, and infrastructure orchestration. Scripting is the formalization of steps required to perform a task. For example, we can write a bash script or use a programming language like Python to automate repetitive tasks. The main advantage of scripting is that we can execute a set of instructions reliably and repeatably. Configuration management tools identify the resources that make up a solution and define how they work together to achieve a common goal. This is also known as infrastructure as code. And the last form of automation is infrastructure orchestration. Infrastructure orchestration tools automate the entire lifecycle of a solution and implement a plan for delegating resources to each application making up the solution. So now in this figure, we can see the 3 levels of automation. Scripting is the most basic of the 3 and involves using scripting languages such as Bash and PowerShell, or programming language like Python. Configuration management provides a layer of abstraction over scripting and relies on tools like Azure Use Management templates and platforms like Chef and Puppet. Infrastructure orchestration is the highest level of automation, and Terraform is one of the most popular infrastructure orchestration tools.
Awesome. So the first step in our automation journey starts with scripting. Now, as you just told me, Foteini, scripting is nothing more than putting my command line utilities into a file, perhaps with a bit of flow control or parameterization to make it more adaptable. The concept of scripting has been around almost as long as computers. For decades, IT workers have interacted with computers by typing commands into a console, and that's me, right? To this day, some users prefer a command line interface to a graphical interface. That's me as well. Now, the simplest way to automate cloud deployments is to assemble the commands that we need to create and configure those resources into a script. The popular cloud platforms all support command line interfaces and cloud shells. Those are command lines that we can go to through a browser, featuring commands that we can use in these scripts. Azure, for example, has the AZ command, while AWS supports the AWS command and Google supports gcloud. Now, one of my favorite books is written by Neil Ford, the productive programmer. He has a joke about humans doing scriptable tasks. So computers are designed to perform simple repetitive tasks. As soon as you have humans doing repetitive tasks on behalf of those computers, the computers all get together late at night and laugh at you, right? Scripting helps us lean on computers for what they do best, taking a set of instructions and executing them exactly. Now, we've had a question come in. And we're going to get at, and the question is Bash or PowerShell a better scripting environment for Azure? Now, we're going to get into a little bit of what Bash and PowerShell is in just a moment. But Foteini, do you have any experience with Bash or PowerShell?
I just used Bash one time.
Okay.
I haven't used PowerShell before.
Yep. So Bash and PowerShell are both very powerful environments, and both have strong capabilities for automating Azure. A lot depends on which one's better. Really depends on what your experience is and coming in. If you have experience with PowerShell, the Azure PowerShell stuff is probably going to be really powerful for you. If you have a lot of experience in Bash, then automating the AZ CLI in Bash is probably going to fit best. Both have their strengths and weaknesses, so I wouldn't necessarily say one's better than the other. I say learn them both because they both can help you out. So, and let's get into what these scripting languages are. Now, a scripting language is a programming language that's used to automate the execution of tasks. From the standpoint of an administrator whose goal is to automate activities involving cloud resources, scripting languages typically fall into two categories. General purpose scripting languages like Bash and PowerShell, they tend to be command shells that also have some scripting capability. And then fully featured programming languages like Python that we can use for scripting. Now, the general purpose scripting languages offer abilities for branching, looping, decision making, but they tend to rely on operating system level commands or commands from add-ons such as the cloud CLIs to do the bulk of the work. Now, one of the benefits that we'll see from using a programming language for scripting is that it's got robust error handling and support for debugging. Now, the downside is that we need programmers that are comfortable in those languages and are knowledgeable about the cloud platforms and the cloud SDKs or software development kits that allow you to more easily access those environments. We're going to take a quick look at a couple of what it would look like in a couple of scripting languages. So we have Bash, which is short for the Born Again Shell, which is one of the most popular scripting languages out there. It is out there on Mac, Windows, Linux, and it's also available in the Azure Cloud Shell, and supports tools like the Azure CLI, the AZ CLI. And we can see an example of what it looks like to create a resource group and a VM with the Azure CLI and Bash. Then we have PowerShell, right? And another scripting tool that's out there that's popular is PowerShell. PowerShell is where I have a lot of my experience. And Microsoft built PowerShell to be the latest generation of Windows command line and offer a more secure alternative to the Windows script host. It's become an open source project in the last handful of years and works on Windows and Linux, as well as Mac OS. Now, one of the differences that we'll see in PowerShell is that the consistency in the native commands called commandlets. They tend to follow a verb-noun pattern, and they tend to be task-focused. So we see commands like new AZ resource group and new AZ VM. The verb-noun pattern helps with command discovery and figuring out, what commands you need to do what jobs. Then we have Python programming. Okay? Administrators also have the ability to use full-featured languages like Python to manage their cloud resources. These languages typically don't include cloud-specific features on their own, but they can use libraries and software development kits that do. Now, most of the major cloud service vendors provide free software development kits for interacting with their platforms. Microsoft, for example, we have Azure SDKs for C#, Go, Java, Python, Node.js, and other languages, as does AWS. Even without software development kits, programmers can usually use the REST APIs offered by those vendors to invoke cloud services. The software development kits and libraries just make that job a little bit easier. So, Foteini, now we've kind of got an idea of what some of these scripting languages look like. Can we look at how we could take a command line experience and turn that into a reusable script?
Yes. So we will use Bash to create a virtual machine and then install a LAMP stack via the Azure Cloud Shell. So this is one of my first times using Bash to create an Azure resource. So if you haven't used Bash before, don't get discouraged and just see this exercise. So sign in to Azure portal and then select the Cloud Shell in the top toolbar, or navigate to shell.azure.com and then select Bash from the drop-down menu. Now, the first step is to create a new resource group using the AZ group create command, and then select the name from the resource group, for example, CMU-RG, and a location such as East US, and then press enter. After running this command, you will see some information about the new group, and you can also see the new group in the portal. So I will refresh the window. Okay, nothing happens. Sometimes
it takes a little bit of time to catch up with what you've run. That's all right. Yeah. We can check back in. I think if we move on a little further, the portal will catch up.
Yeah, I will move to the next step, which is to create a new virtual machine using the AZ VM create command, and then I select the resource group that I have just created, which is named CMU-RG. Add a backslash to go to the next line and select the name. For example, lamp-cmu-vm, and choose Ubuntu LTS and CMAX. Then you can select an admin username, for example, lampadmin. Instead of specifying login passwords, you can use the generate SSH keys, which replace login passwords with public-private key pairs for added security. So I write generate SSH keys, I add a backslash, and the last step is to choose a location, and I will choose again East US.
Now, I've used Bash before, and usually your command will just be all on one line. So I like how you're using the backslash there as a line continuation to kind of break it up and make it look a little easier. It's a pretty nice trick. All right, yeah. And now, Foteini, you've mentioned too, you've got LAMP in there, and you've said LAMP a couple times. What's LAMP, or what's the LAMP stack?
Yeah, LAMP means Linux, Apache, MySQL, and PHP. And so we are going to install a Linux operating system, a web, and a database server in our virtual machine.
Oh, okay.
And the operation has been completed, so we can install the LAMP stack via the secure shell. And we can also see some information about the new virtual machine, and we will need the public IP address for the next step, so copy it. Now we can connect to the virtual machine via the secure shell using the SSH labadmin, which is our admin username, add the public IP address and hit enter.
So it's going to use those SSH keys that you generated as part of the VM creation to authenticate you, right?
Yes.
Okay.
And I enter yes to confirm the connection, and now we can write our commands inside the SSH session. We're going to use two commands to install the LAMP stack. The first one is sudo apt update, and we will wait for the operation to finish, and then we will type the next command, which is sudo apt install LAMP server, and we will install the LAMP stack. So I'll add the second command. And I made people.
All right, this is live, and this is actually when we were talking before about why automation is important, right? Is if you had to do this over and over and over again, that those are all potential points for you to mistype something or to install a slightly different package, use a slightly different base image, right? There's a lot of stuff to remember and keep track of as you're going through all the steps.
Yeah, I agree with you. That's a lot of steps, and especially if you execute them not just once but several times. So
should we take a look at the Azure portal and see if it's caught up any for us?
Yes.
Ah, there we go.
Yes, this is our new resource group.
Yeah, we got all of our resources there that were created by the command. Now, it's nice the Azure CLI command did create a couple of different things to create that virtual machine. There's a network security group, a public IP, a network interface, a virtual network, all the kind of different components, right? And so instead of the cables that you'd install in the data center, there's different software components there that represent all those different concepts. Now, how's our process coming along here?
I think that the operation has just finished.
Wonderful.
So I can now terminate the SSH session using the exit command. And we can move on to the next step, which is to create a script containing all of these statements. So I have already created and uploaded the script. And the commands in the script are similar to the commands that we type in the console, but there are some differences. For example, we use the AZ vmshow command to get the public IP address of the virtual machine, and then we assign it to the variable IP address. We use the redirection sign to inject commands into the SSH session, and the -y statement to suppress confirmation prompts so that the script can run from start to finish without human intervention. And we also use the sleep 30 seconds command to ensure that the creation of the virtual machine is finished before starting the SSH session. Now we can use the chmod +x ccvm.sh command, where ccvm.sh is the name of our script, and hit enter to create the script, to make the script executable, and then I can just use the name of the script to run it.
Awesome. So while that script's running, I just wanted to share, Andrew shared in the chat that regarding the live points, it's actually useful to know. I'm trying to pick up some skills and experience. Thanks both. So thank you, Andrew. Appreciate you sharing that feedback as we're going. And yet, Foteini's been sharing some great stuff with us here. So let's see how our script is coming along. So it looks like I see a resource group got created as we're going.
Yes.
Now, yeah. So So what this script is going to go through and do everything you just did before, except with you only having to type in one little thing, the short name of the script, right?
Yes.
Is that awesome? So removes a whole lot of possible, user error parts.
Yes, we can execute exactly the same statements using only one command. But this is not perfect because every time the script is executed, it attempts to create the same virtual machine and the same resource group in the same region. And so if we want to create identical virtual machines in different regions, we have to modify the script.
Yeah, that can be a problem, but one of the nice things about it being a script, right, is that we can parameterize it, and we can give it some the ability to you could provide some input as it goes in, right?
Yes. We can modify the script, but it will become very complex, so it is not a good idea.
Okay. Well, I think we're going to talk about some of those challenges that we may face when we look at scripting as our ultimate solution, and as soon as we get through this provisioning. Now, I see a lot of the same stuff happening from before. Do you want to wait for this, or should we move into the next? Should we start moving into the next section here?
I think we can move on to the next section.
All right, sounds good. All right. So let's get back to our slides. And as we were just talking about, Foteini, scripting can provide some additional consistency. It can make some more complex things a little more straightforward. But we do have some problems. We do have some potential areas of pain as we develop those scripts. And some of those are around complexity, item potency, cloud specificity, how we use version control, and how it interacts with other automation. Now, to do, every time that we have to add parameters, for example, what we were just talking about, right? How do we make it use different regions? How do we change the VM name? How do we change, any of the inputs into that script? Well, we can either go back and edit that script, or we can take in some parameters and make some decisions at runtime. However, this leads to complexity that we have to test for and that we have to account for, because if we run this stuff in our production environments, we can do some, and we change them in a way that prevents the software that we have from running. We've just created an outage, and that's usually not a happy day. Next challenge that we tend to see with scripts is when we operate in a cloud environment, we expect that the operations that we do, that they're idempotent, meaning that if I run the command multiple times, I should get the same result. Now, some command line tools are already idempotent. They're just designed with that in mind. But others, we have to add logic to our script, which goes back to point one. We will make it more complex because we're adding some logic to it to achieve that result. You have cloud specificity, right? Where the AZ commands are going to be different than the AWS commands, which are different than the G-Cloud commands, which are different than the commands that you're using inside your data center to provision things. So your scripts have to understand the environment that they're going to talk to. Now, this is one thing that we as an industry, I think, have not been so good at, and that's treating the scripts that run our infrastructure with the same care and professionalism that we treat the software that we develop. Now, scripts belong in source control. It gives us history, change tracking, and it lets everyone know what the current version of the script is. As I mentioned before, right? If the automation that drives our production environment takes down our production environment, it doesn't matter how good the software is that's running there, because people can't consume it and use it. So I think we need to take the same level of care with our infrastructure automation that we do with the software that we run in that infrastructure. And finally, the last major consideration that we have to deal with when we automate cloud environments is that these things don't live in a vacuum, right? Other automation, whether it's from UIs, whether it's from other tools, other scripts, whether it's from somebody logging into the portal and doing something, these things can all modify the environment that our software is running in. So our scripts need to be able to grow the ability to respond to these uncertain starting points, which adds complexity to those scripts. So, scripting is a wonderful capability, but it is not without its downsides. Now, one of the great things about Microsoft Learn is we have these knowledge checks throughout the Learn module that kind of help make sure that we're getting the key points out of the lessons that we're going through. So now we've got a basic understanding of scripting and some of the positives and negatives. Let's get the audience involved a little bit with a knowledge check. And if you're watching on anything other than Learn TV, head over to aka.ms, Learn Live TV, and you can answer these questions along with us. So, question 1. In the context of scripting, which of the following scenarios demonstrates idempotency? So we're going to leave the question up, and Foteini, you and I will walk through the different answers here as the audience has a chance to try out the answers as well. All right. What do you think about C, which is a single script run twice, creates one virtual machine the first time it's executed, and a copy of that virtual machine when it's executed again?
So in this case, we create a virtual machine the first time and an identical virtual machine the second time. This scenario does not demonstrate idempotency because idempotency means that a script run twice produces the same result and has the same effect on the system.
Okay. Let's try, how about B, which is each time it's executed, a script verifies that each of the resources it attempted to create was indeed created and logs any failures that occurred.
I don't agree with this answer because idempotency is not about recording the failures that occurred when creating resources.
Okay. And let's try A. How about this? Each time it's executed, a script writes a record of the resources it created to the machine log.
Yes, I think that this answer is also incorrect because idempotency is not about recording the resources that the script has created.
Okay. Well, I think that takes us to D. Now let's before we kind of cover that one, let's take a look, let's peek in and see how we're doing in the poll. Right now it's split dead even between C and D. So you thought it wasn't C, and we're about to talk about D. So let's see who's getting it right here in the poll. So D is a single script which is run twice, creates a virtual machine the first time it's executed, and then uses the existing virtual machine the second time it's executed. What do you feel about that one?
Each time an idempotent script is called, it will have the same effects on the system. This means that the first time we create a virtual machine and then we use the existing virtual machine. So I think that this is the correct answer.
Yep, and D is pulling away in the chat as well. So I think D is our correct answer. And yes, because idempotency means that we get the same result every time we run. If we run that script once or multiple times, we should get the same result. Because we didn't talk about switching out parameters or anything else, so we would expect that D is our answer. All right, I think we've covered scripting pretty well. Let's move on to talk about infrastructure as code. Foteini, you want to take it away for us?
Yes, so the next step of our journey to cloud automation is infrastructure as code. Infrastructure as code provides a mechanism for defining what a solution looks like, and it defines a solution in a dynamic way, like a program. Infrastructure as code contains many of the elements of a program without necessarily relying on a programming language. For example, in infrastructure as code, we can import modules or use functions, classes, conditional blocks, error trapping and recovery, and we can have support for testing and debugging. Infrastructure as code relies on configuration files. These files are similar to source code, but are not written in traditional programming languages, and they don't include step-by-step procedures like a Python program or a PowerShell script. A configuration file defines an outcome and a process for achieving that outcome.
Yeah, I think that's the key there. Now, before we get too far, we did get one other question come in about the scripting and one of the challenges I mentioned, which is version control. And the questions: should we use Git or something like SharePoint to version our scripts? And I would strongly recommend Git or some other version control program, not something like SharePoint. SharePoint's versioning is more around like document collaboration, editing, where Git or something like Subversion or Team Foundation Server, like there's a lot of other source control methods. Git is currently one of the most popular and well used that supports those tools to begin with, and it works well for this infrastructure as code, these infrastructure as code definitions as well. So, if you're using some sort of version control, I'm not going to be mad at you, but you should definitely be using some sort of version control. It is a really good one to get familiar with. So, all right. Thank you for that definition of infrastructure as code, Foteini. And one of the things that we find when we start talking about infrastructure as code is we really start this discussion about these two historically separate departments, IT administration and software development, and how they should come together. And the DevOps movement came into being from this idea that that any plan at this level of business can't be undertaken by organizationally separate teams. And the reason that we see this is because we typically would see developers incentivized to deliver new features and IT administrators incentivized to keep environments stable. And what makes environments unstable? Changes. How do you get new features into production? You make changes, right? So you have one team that's told make changes so that we can get new features. The other team getting told don't break anything, so therefore we must block changes. And so this would lead to this ongoing tension in organizations. Now, so that kind of gave rise to this idea of DevOps, and the term really came about from a conference back in 2009, where two of the speakers, John Allspaw, who headed technical operations, and Paul Hammond, who was the head of an engineering team, they were at Flickr, and their joint session introduced the idea that if data center infrastructure could be made adaptable and responsive to the changing workloads, then they could support applications and services with much shorter release cycles, so they could deploy much more quickly and focus on this idea of continuous improvement. Now, this idea of DevOps is pretty powerful and has led to some appreciable impacts that we see in the industry. So thanks to agile software development, we see the ability for software teams to deliver software faster. DevOps helps us extend that process by integrating infrastructure as code into our continuous integration and continuous deployment models. But when we start to restructure our teams so that we have the objective of the project or the objective of the product, as opposed to the objective of the org chart, we tend to see that that these results tend to be stronger. We see testing become a much more serious and rigorous process, in large part because in order to deliver software faster, we have to have automated tests. We can't wait for manual tests of everything. We start to see infrastructure management tools integrated with that CI/CD process that I just mentioned, right? And then in order to kind of mirror the process that's happening in development, but also to better handle the flow of work in the organization, we see that the project management methods that software teams use now being used by IT teams. So we see them adopting Agile, we see them adopting processes like Kanban or Scrum, and it has a tremendous impact in the way that work is done in the operational side of the house. So I think it's time for another knowledge check, right? So pop on over to aka.ms, learn live TV, and play along. So Foteini, which of the following statements best describe the primary purpose of infrastructure as code? So we have A, which is the principal objective of infrastructure as code is to simplify the process of deploying cloud resources to 2 or more cloud environments. What do you think?
Yes, some infrastructure as code tools can be used to deploy a resource to multiple cloud environments, but I don't think that this is the primary purpose of infrastructure as code.
Okay. Well, let's take a look at B. The principal objective of infrastructure as code is to ensure the high availability of virtual machines and other cloud resources.
So availability is very important in a cloud computing environment, but infrastructure as code tools does not address availability.
Okay. Well, we got some answers coming in the chat. So far, we're leaning towards D, but let's take a look at the next answer in our list here, which is C. All right, Foteini, how about the principal objective of infrastructure as code is to define a process for achieving an outcome, for example, the process of provisioning a set of cloud resources, without having to define the outcome itself?
So that's a tricky one. With infrastructure as code, you define the outcome that you want, and infrastructure as code tool creates a process for achieving that outcome. So this is false. Okay.
Well, our audience is weighing in at fully in support of D. So let's see what our D reads as. The principal objective of infrastructure as code is to make the composition of a solution that's deployed to the cloud both explicitly definable and dynamic like a program. What do you think about that one?
Yes, I think that we all found the correct answer. Because as we mentioned before, infrastructure as code tools define a solution in a dynamic way, like a program.
Yep, exactly. And the primary focus of infrastructure as code, as you mentioned, back when we first started talking about this, is really that idea of I wanted to find a definition of what it looks like, and then let the tool do the work of getting it to that state, regardless of where it started from, and that's really where the approach differs from scripting. So we've covered scripting and some of the tools that are available there. We just learned about infrastructure as code as a concept and the idea of DevOps. How about we take a look at some of the infrastructure as code tools? Foteini, you want to take the lead on this?
Yes, I will be glad. So the main purpose of a configuration management system is to define a state of the solution. Configuration management tools identify the resources that made up a solution and define how they work together. And we have 2 main methods to achieve that, the imperative method and the declarative method. So let's start with the imperative method. In the imperative method, we record the exact sequence of instructions required to create or maintain a resource, like a virtual machine, and the end state of the solution is the result of executing all these instructions sequence. For example, in the previous demo, we executed a sequence of bash commands to create a resource group and a virtual machine. On the other hand, the declarative method focuses on what the program should accomplish without specifying how the program should achieve the result. This means that we don't use commands to describe how to accomplish the final solution as we did in the imperative method. Here, the end state of the solution is defined outright, and the system maintaining that infrastructure sets up a plan of operations whose result is the declared state of the solution. And now there are pros and cons to both approaches, and the choices that enterprises make when choosing a configuration management platform and an infrastructure as code methodology depends on their needs.
All right, so let's take a look at a couple of different implementations of infrastructure as code tools. Now, since this is Microsoft Learn, and we're talking about, I come from the Azure team. Let's get specific about a tool around Azure. Now we have Azure Resource Manager templates, which is a system for generating explicit specifications for one or more cloud resources. The Azure Resource Manager template's designed to be a complete inventory of the values and parameters needed to execute the Azure instructions for provisioning new resources or updating existing ones. And this is a domain-specific language built on top of JSON. And in the document, in the template document, we have a couple of key sections. There's a parameter section for defining what parameters the template will accept. So this provides your entry point for variance. And then we have a resources section, which has all of the resources that the template will either create or update. Now, a template can also include other sections, things for custom functions, variables, so you can define some values that can be reused throughout your template without having to redefine them every single time. And you can also specify outputs, right? So we're going to create some infrastructure, and there may be some important information that we want to get back as part of that provisioning process. And the output section allows us to define those things. Now, the example that we have up on the slide here is a very simple template, though it's a rather long stretch of code there that defines how we can specify a storage account. And there's an example of a parameter in there. And you can find a ton of other examples of Azure Resource Manager templates out on GitHub if you are so inclined. Now, let's see what we have next. All right, how do we deploy these things? Azure Resource Manager templates, we can either deploy them with the command line or PowerShell commands, so the AZ CLI or Azure PowerShell. We can use applications written in C# or in other programming languages, or we can go directly to the Azure portal and we can deploy those templates from the Azure portal. For example, on the slide here, we see what the portal experience looks like. And we have an opportunity to create a new resource group to deploy the template into, or we can specify an existing one. We get inputs, including dropdowns if we've got specific parameter values that can be provided, or free text fields for other inputs. And now, Foteini, do you have any experience working with Azure Resource Manager templates?
No, I haven't used Azure Resource Manager templates.
So I've got a surprise for you. If you've used the Azure portal, you've used Azure Resource Manager templates. They're just kind of hidden back behind there. Almost all the experiences that you have in the Azure portal are driven by Resource Manager templates. So when you want to create a new resource, very often there'll be like this automation options or scripting options button just before you hit create, right? And that can show you the Resource Manager template that the portal is going to use to create your resource. So whether you know it or not, Azure Resource Manager templates are helping you today. Now, let's talk about a couple of other tools. So whenever we talk about infrastructure as code, there's two tools that always come up. The first ones that come up in any discussion, that's Puppet and Chef. So Puppet is the modern day form of Luke Kane's 2006 experiments with extending an abstraction layer over multiple servers operating systems, right? It really comes down to having an engine whose main job is to take an input specification of the desired state and determine the sequence of steps necessary to get that system to that state or near that state, and then to execute those steps. And one of the fundamental things that we see about a lot of these infrastructure as code tools is this idea of eventual consistency. And that's the point of getting near. Like, what are all the steps I can complete successfully? And then maybe I have to wait for the a system reboot or just another pass of applying these changes to be able to take the next steps, because not everything can be accomplished in one pass always. And so Puppet and Chef embrace that idea, and so that's why they'll try to get you at least near that state, and then they'll keep trying to get you to that end desired state. Then we have Chef, right? And so Chef's powered by agents that look into a system state, report back its configuration status. Puppet also does this kind of information gathering, right? And what these tools enable then is that your configuration management templates can have some understanding of the environment that they're being deployed in, so they can make choices about what automation to run. Now, the servers are designed to be operated remotely, so you have all these agents checking into a server to get some information back, so that they can make determinations about what to do next. Now, implementation-wise, there's some differences between Chef and Puppet, but conceptually, at a very high level, they do a lot of the same things. Now, Ansible is an orchestration tool that often performs configuration management tasks. So it is often brought into this configuration management discussion. Now, its goal is to provide a single script that installs, configures, and maintains given services or applications on any server infrastructure. Now, unlike Chef and Puppet, which tend to be pull configuration, so they tend to pull their configuration policies from their server infrastructure, Ansible's a push model. So you tell Ansible to go out and target these nodes, and so it is an agentless environment. So they'll connect over SSH or WinRM to these remote machines, or call out directly to APIs, and then it can gather information, use that to help determine what policy to run. So there's no remote agent actually processing the Ansible. And the Ansible DSL, the domain-specific language, is in YAML, as we can see on the slide. So ultimately, configuration management simplifies the job of managing these cloud resources, similarly to how a combine harvester simplifies the job of gathering grain from the field. And CM tools, they elevate the role of the system administrator from a task-based execution to a profession where we're responsible for building and evolving these definitions over time and understanding how they interact. It's kind of big picture aware and finding ways to integrate new configurations into existing systems rather than just reacting to the changes that like a script would make. So, Foteini, do you think you'll explore any of these configuration management tools as your career progresses?
Yes, the field of cloud automation is very interesting, and I think I will explore some of these tools. Okay. Maybe I will start with the Azure Resource Manager templates.
That's a great place to start. Now, we had a couple of questions come in as well. And so we got one question is, what type of tasks do infrastructure as code tools perform? And infrastructure as code tools perform just about any task that's scriptable or API driven. So when I would teach configuration management, we would often start with, how do I automate this from the command line? And then that becomes the basis for how I'm going to approach automating it with a configuration management tool. Now, the infrastructure as code tools that talk about cloud environments, then we start looking at, okay, what's available from the REST APIs. In the case of Azure, we look at the Azure Resource Manager APIs because the templates are a direct input to those APIs. So basically anything that can drive and change in our environment that we can drive from an API or from a command line tends to be a task that infrastructure as code tools perform. Now, it's usually provisioning or state setting. There's usually not like operational tasks. Like if I wanted to take a backup log of something, that's not something our infrastructure as code tools would necessarily perform, unless there was a job that we would schedule to do that, and you're creating the scheduled job with infrastructure as code. Now, the other question that we have is, what steps should you take to choose the right infrastructure as code tool? Foteini, do you have any ideas here? I mean, I know this is a new field for you, but you have any thoughts on what steps we might want to take in choosing the right infrastructure as code tool?
I don't really know.
Okay. That's fair. And you're just seeing this question now, so I kind of put you on the spot. Really, in my experience, what it comes down to is what skill set does my team have now? What target platforms are we working on? Are we talking about physical machines, virtual machines, cloud resources, right? Different tools are going to have different sets of capabilities. They're going to use different domain-specific languages, like the ARM templates are JSON variation, and so it really comes down to a lot of what fits the operating environment that you have, as well as the skills that your team has, and then what training resources and things you have there too. All right. I think we need to step into our next knowledge check. All right, we ready for this one, Foteini?
Yes, I'm ready, and I like so much this part of the Microsoft Lab.
All right, so this is our longest question of the night. You are creating an Azure Resource Manager template that defines a cloud solution comprising virtual machines, storage accounts, message queues, and other resources. The template's written in JSON, and at runtime, you want to require users to select the Azure region where these resources are deployed. What's the proper way to accomplish this with an Azure Resource Manager template? So let's take a look at our answers. Now, we'll give folks a chance to answer in the chat too, and then we'll check in on them. But Foteini, what do you think about B, where we define the region as an input parameter in the template's resources section?
A resource section is used to define the Azure resources that the template will create or update. So I don't think this is the correct way to define it in parameters.
All right, fair enough. Let's pop down and try D. None of the above. Azure Resource Manager templates do not support user-defined parameters. What do you think?
So I think that this is incorrect because Azure Resource Management templates support user-defined parameters. And in fact, by providing different values for input parameters, we can use the same template for different environments.
Great point. That's something that when we talk about infrastructure as code, we often talk about the structure of the environment, and then the environment data being separate ideas, separate concepts. So we could take environment data and layer it on top of the template to get those different environments out without having to change things. And then that lets us have test environments that are very similar to our production environments, meaning our test experiences are going to relate much more strongly to what we have in production. And when we get to production, we'll have a much better experience. So great call out there. How about C? We write a custom script that prompts the user to select a region and invoke the script from the template.
So I think that this is a really hard way to achieve the result. So I don't agree with that.
Okay, so I just checked in, and we do have a couple of people in the audience voting for C to get that custom script. Now, that is a way we could wrap it in a script, wrap the execution in the script, but I think there's a better answer here. How about A, right, where we define the region as an input parameter in the template's parameters section?
Yeah, I think that this is the correct answer because the parameter sections enables you to define parameters that the user provides when the template is executed.
All right. So just checking back in on the poll in chat there, and we've got a split. A couple people voted for C. A couple people we got a vote for A. A is our correct answer, but those of you who voted for C, don't worry, you're not that far off, because that is one technique that you can use to prompt for a region. Rather than having the script as part of the template, you use a wrapper script to call and run the template. But yeah, so that it's pretty close to a pretty common technique. So great. Now I think it's time for us to step into our next topic area, which is going to be Terraform. Now, Terraform is an infrastructure orchestration tool. It was created by Mitchell Hashimoto, who's a veteran chef and Puppet user who thought about infrastructure in a slightly different way. Now, if you come from a background of working with Chef or Puppet or CF Engine or PowerShell desired state configuration, very often when you're looking at configuration management, you look at it as a problem starting with the virtual machine and then expanding to the environment. When we look at Terraform, Terraform talks more about our environment and setting up the environment as a whole, and then possibly even delegating down to tools like Chef or Puppet for individual component configurations. Now, Terraform's goal is to produce a provider-agnostic, though technically complete view of cloud infrastructure and services and applications that make use of it. And it does this through a plugin system and provider system. So you can create providers for Azure and AWS and Google Compute and VMware and a number of other operating environments. So Terraform gives you the capability to reach out and manage all of these individual things. And then you can also plug in different configuration management tools and say, hey, if I spin up a virtual machine, I want to configure this machine with Chef, or I want to configure it with Puppet. So Terraform provides a different view and a different approach to configuration management than, for example, your experience would have been with a more traditional configuration management tool. Now, Terraform syntax, it looks a little different than what we saw with scripting. It's pretty similar to what you might see in other configuration management tools because we talk about defining the end state. So we have a lot of key and values, but Terraform uses a domain-specific language that it calls the HashiCorp Configuration Language, or HCL, to create its environment definitions. Now, Foteini, have you ever had a chance to try Terraform out? Then would you like to walk us through an example?
Yes. So again, sign in to Azure portal and open the Cloud Shell. This time I'm going to use Terraform and create a Terraform execution plan that allows us to preview infrastructure changes, and then we will apply the execution plan to our cloud infrastructure. And so I have already created an infrastructure and Terraform execution plan, and we can see it here. So a Terraform execution plan starts with the specification of the provider, and then we can declare the resources. For example, the resource group declaration has two arguments, a name and a location. As we can see here, we have a name which is CMU-TF-RG and a location which is US. Then we can declare other resources such as a virtual network, a subnet, or a virtual machine. The first step is to initialize the Terraform deployment using the Terraform init command and press enter. And then we can create our execution plan using the Terraform plan command, which allows us to create a report. So I write Terraform plan.
You got a typo.
Yeah.
So Foteini, did you have to do anything special to get Terraform in the Azure Cloud Shell?
Yes, I created a new directory called Terraform, and then I just use my Azure credentials to verify the Terraform deployment in Azure Cloud Shell.
But the tool was the tool was already installed in the Cloud Shell for you?
Yes.
Oh, wonderful.
And so Terraform has completed its analysis, and before it makes any changes, it presents us our execution plan as a detailed report. So in this report, we can see the actions that Terraform will perform if we apply the execution plan. And this report allows us to verify whether the execution plan matches our expectation and before making any changes to the actual resources. So this is our execution plan, and we can apply it to our cloud infrastructure using the Terraform apply command and hit enter. And then we have to wait for a minute. So I enter yes to confirm the changes. And I think that everything is working. Yeah.
So Foteini, we had a question come in while you were working there. Is Terraform the best choice for infrastructure as code? Do you have any thoughts or preferences? I know I have a few thoughts on that, but how about yourself?
So Terraform is the only infrastructure as code tool that I have used. But I think it's a pretty easy tool to start with because I only created a configuration file and use only 3 commands to create the infrastructure.
Yeah,
But yes.
go ahead. I'm sorry.
But I want to hear your answer because you're more experienced in this field.
All right, so yeah, Terraform is I wouldn't say it's the best choice. It is a good choice. Because Terraform has this provider model and has targets against all these different environments, very often the environment, whether it's like Azure, for example, when a new feature comes out, it's going to be supported first in the Azure Resource Manager templates. And because it's because the templates are part of the, they help drive the API, so the modeling is all just there. And it may be a little bit of time then before that capability gets added into the Terraform provider. So there's I think there's a little bit of, if you're targeting multiple cloud platforms, Terraform's a great tool. If you don't mind not having the latest and greatest on day one, Terraform can be a great tool. Terraform has a great development experience. So there's a number of factors that you have to consider. So unfortunately, it's not just a straight yes or no answer, right? How's our process coming along here? Does it look like looks like our machine's getting created? Is that correct, Foteini?
Yes, everything is created now, and I think I can refresh this window. So here is the new resource group, and we can see our resources.
Oh, wonderful. So one of the differences that I've noticed here in this approach with Terraform and then what we did with the Bash script and the Azure CLI is with the Azure CLI, we had one command to say, give me a VM, right? Here, to get the VM, you had to define the disk, the network interface, the network. So it seems like there was a few more things that you had to care about. And that's one of the things I've noticed with infrastructure as code, right? Is we have to be much more explicit. The command line tools you can be explicit like that with the command line tools, but they can also make some more assumptions for you. Like if I just say new VM and I don't give it a network interface, it knows to go create one for me. But because we're creating a declarative model saying, I want this to be this and this to be that, and I want the network interface to look like this, and I want the VM to be this, right? We're being much more explicit about what that environment is. We have to specify all of those things. So just something I've noticed as we were going through these examples and some of the other capabilities there. But awesome. So what else? What else does Terraform do for us?
So after creating the resources, we can destroy them using, again, a Terraform command, which is Terraform destroy. And after running this command, all the infrastructure will be destroyed. I enter yes to confirm the changes. And yeah, everything is working, I think.
Yeah, so that's great for if I'm trying stuff out and I want to create and destroy, or if I need to, if I'm spinning up a new production environment and taking down an old one. That's cool. It can know all the environment, all the things I specified about that environment, and then be able to pull them all down in the right order. That's very cool. All right, well we'll let that continue on to destroy all those the VM related resources there, and I think we've got a knowledge check coming up. So let's pop back over to that. So we just finished creating some cloud resources, and now we have our last knowledge check. So if you're not there yet, head over to aka.ms, learn live TV, and we can answer this last question about Terraform. Which of the following statements about Terraform is true? Let's start with B. Terraform is compatible with popular configuration managers such as Chef and Puppet, but cannot be used to manage resources that are already being managed by those configuration managers. What do you think?
So I think that this is incorrect because Terraform can be used to manage resources that are already managed by other configuration management tools.
Yes, and this is actually one of those complex or the interaction with other automation tools problems that we mentioned with scripting, right? Is other things can step in and adjust our environments, and so they can kind of step on each other a little bit. All right, how about D? Terraform uses a declarative language that's identical to JSON.
As you said before, Terraform uses a declarative language that is unique to Terraform.
Yep, HCL, right? Yeah.
Yeah.
Now let's try C. Terraform can be used to deploy and manage virtual machines, but not containerized solutions.
I think this is also incorrect because Terraform can be used to deploy different types of cloud solutions, including containerized solutions.
All right, let's check in on where our audience is at. It looks like everybody is unanimous for A right now. So let's see how that comes out. So A is Terraform supports any cloud platform which a resource provider is available for and can be used to deploy resources to multiple cloud platforms. What do you think?
Yes, I agree with our audience. Terraform is available in many cloud platforms.
Yep, exactly. Now, one of the things that we might see though is because there are differences in the cloud platforms and services they offer, what I designed for Azure might not spin up exactly the same in AWS or in Google Cloud. So while Terraform can let me target all of these things, I do need to be aware of the differences in those target platforms. So good, just a little something to be aware of as we go through this now. So we've covered a lot of ground, in the last hour and 15 minutes. How about we recap some of these important parts, Foteini?
Yes, I'll do it. So in this session, we talk about cloud automation and the three forms of automation, which are scripting, configuration management, and infrastructure orchestration. Cloud solutions are often complex, consisting 10 or even hundreds of resources that must be provisioned and configured to work together. And this is why we need automation, because automation helps you deploy and update the solution reliably and repeatably. One way to achieve automation is scripting. Scripting is based on scripting languages like Bash and PowerShell. One disadvantage of scripts is that they can become very complex because they must anticipate every condition that the human might encounter. Another way to achieve automation is to use configuration management systems such as Chef, Puppet, or Ansible. Configuration management systems incorporate the concept of infrastructure as code, in which the state of a system is defined using a declarative or an imperative language. With infrastructure as code, you can make a change to a system by changing the code that defines it. And the last form of automation is infrastructure as code, which provides a higher level of automation and automates the entire lifecycle of a solution. An infrastructure orchestration platform, such as Terraform, plans for the implementation of all services a solution may require, and renders the plan in a way that can be reviewed or even rejected before it is implemented.
So we had a question come in as we were going regarding Terraform. So and is it regarding solution type that it depends on the environment, the platforms, or use case? So I think what the question is asking is if Terraform is Terraform as a choice, or the variation kind of depend. So because each cloud provider models resources differently, right? At a very high level, a VM is a virtual machine. But how AWS implements it and the networking stack around it is going to be different than how Azure does, which is going to be different than how Google Compute does. And so I could ask Terraform for a VM generally, and I could point that pretty much to any cloud platform, most likely. However, when I want to start taking advantage of some of the capabilities of the individual cloud platform, then I need to get more specific and say, okay, I'm targeting this, and this configuration is really going to be focused on Azure, or this was going to really be focused on AWS, or really going to be focused on Google Cloud. So that's where things start to get a little more specific. We still get to use the same language and the same tooling and the same workflow and patterns, since I'm using Terraform to target multiple environments. It's just that I can't necessarily take the exact same definition and point it at multiple cloud providers and expect it to work perfectly. So I hope that helps, Andrew. And now we've had this chance to go through and learn module. Please head on over to aka.ms/CMU Automate Cloud and start your journey on Microsoft Learn. If you sign in there, it'll track your progress through. You can earn some badges and all sorts of fun stuff there. And I'd like to remind you that we've got a series of focus events on Microsoft Learn and these Carnegie Mellon modules where we'll go deep into the unit's content. And we've got demos and interactive Q&A just like today with cloud advocates and our student learn ambassadors. You can register for the upcoming sessions at aka.ms/CMU Cloud Monitoring Meetup and aka.ms/CMU Cloud Security Meetup, and catch the recordings of this and the previous sessions at aka.ms/LearnLive. So hope we catch you there. And Foteini, got some last resources for us?
Yes, now that you have got our session and learned the basics of cloud automation, you can go to aka.ms/CMU Automate Cloud and complete this course on Microsoft Learn. If you want to watch our session again or practice our live exercises, go to aka.ms/LearnLive. And please fill in our session survey at aka.ms/reactor/survey with event code 12923.
Yes, help fill out the survey. Let us know how this session was for you and how we can best help you in your learning needs. Now, with that, I want to say thank you for your time and attention today, and thank you, Foteini, for your help today. I think we have a couple of final questions that have come in. You think we got a minute or so for some more questions, Foteini?
Yes,
All right.
I saw one question.
All right, so one of the questions that came in is, can you build and maintain a cloud solution using one infrastructure as code tool, or do you need multiple? What do you have any thoughts on that, Foteini, based on what we've covered today?
I think you can use one tool, like we use only Terraform to create a cloud solution. But maybe sometimes you might need multiple tools to configure a more complex solution.
Yeah, it really is one of those it depends scenarios, and it depends on types of resources. Now, a lot of where a lot of the complexity comes in is when we start spinning up infrastructure as a service or virtual machines, right? And that's where we might transition into some of these other tools like Chef or Puppet or PowerShell desired state configuration, something like that. So. Great. And then I think we have one more question here, which is, do ARM templates, Chef, Puppet, and Terraform perform the same tasks? So, Foteini, thoughts?
So I think that ARM templates and Terraform are mostly used for deploying infrastructure, while Chef and Puppet are configuration management tools for configuring the resources once they're deployed.
You know, you answered that as well as I could. So thank you. That's it, spot on. You know, Chef and Puppet typically target the virtual machine, the deployed resource, and can manage up and out from there. And ARM templates, you know, and Terraform tend to focus on the environment creation. All right. Oh, got one more question coming in. I love this. I love the questions that keep coming in. So what's wrong with using the Azure portal to create infrastructure? I'll let you take a first crack at this one, Foteini, and then I've got some thoughts.
So creating resources in Azure portal is pretty easy, but if you want to create a more complex solution consisting of 10 or 12 different resources that might be provisioned to work together, this might be a difficult task. So with infrastructure as code, you can perform all these tasks more easily.
So that is that's spot on for for some of the information that we shared today. Now, based on my experience, I will say it's not always wrong to use the Azure portal to create resources. If I'm just exploring a new resource type, or I'm doing a one-off thing that's never going to get repeated, then maybe maybe it is time to use the portal to go create that resource. Now, I'll caveat it that one-time thing that I'm spinning up for no reason. Very often that thing can end up as production. Unfortunately, that's a pattern that tends to happen. But ultimately, we want to using infrastructure as code tools or infrastructure orchestration tools is not a for free. There is some cost to it. There's some learning that you have to do, yet some experience that you have to gain. There's some overhead in managing the environments through those tools. You get a lot of benefit from them, but there is a cost. And so you have to determine, is my spinning up and creation of this resource going to be worth the cost of that? And for some experimentation, sometimes no, it's not. Maybe the Azure CLI, maybe the Azure portal is going to be the better option. So it really is one of those it depends scenarios, unfortunately. But you won't go wrong using the infrastructure as code tool for something you're going to be spinning up again, or for something you have to manage over a period of time. Because once you spin it up in the Azure portal, you're not going back to the Azure portal to spin it up again. You're going back to the Azure portal to make changes and use it operationally. So if you have to manage it over time, using infrastructure as code tools is handy as well. All right, I think we've got just a couple more minutes left. So if you have any questions, for those of you who've joined us on the Learn TV stream, please send them in now. Otherwise, Foteini, it's been a real pleasure working on this, working through this with you. Do you have any other thoughts of what next you might tackle in Microsoft Learn?
I don't know, but I would really be glad if you invite me and in one more Learn Live session, because I really enjoyed our today's session.
All right, yeah. So I think for me, I want to do some more AI stuff. I haven't done as much AI. I haven't had as much AI experience in my time working on Azure things. So I want to find some Learn modules on that, and so we'll check that all out. Thank you, everybody, for your time and attention today. Thank you, Foteini, for helping out and going through this content with us and getting to learn a little bit about scripting, configuration management, and infrastructure orchestration. And we'll see you all at the next Learn Live.
Thank you too.